Hi guys, today we're gonna learn about how to calculate the concentration of hydronium ions and hydroxide ions. So we have a solution that contains 1 times 10 to the negative 4 molarity solution of nitric acid. It has been prepared for a laboratory experiment. Now, they're asking you to calculate the hydronium concentration ions for the solution, but also calculate the hydroxide concentration ions. So what we do now is, because we're talking about an acid, we're going to do the ionization of the acid. Now, how are we going to do it? Remember, for acids we combine with water. Okay, so this will be nitric acid. This will be nitric acid plus water. Now remember that this produces H3O plus, the anion. Okay, now we see if it's balanced. As you can see, we have 1 plus 2 hydrogens, so 3 hydrogens, and we have 1 plus 3 oxygens, or 4 oxygens, 1 plus 3, 4, and nitrogen 1 and 1, so it's balanced. Now, after this, we write the number of moles. Okay, 1 mole of nitric acid, we have 1 mole of water, we have 1 mole of hydronium ion, and we have 1 mole of nitrate. Now we're gonna do a molar ratio between the acid, okay, and, because we're talking about an acid, the hydronium concentration. This mole ratio is 1 mole nitrate over 1 mole of hydronium, or it could be 1 mole of hydronium divided by 1 mole of nitric acid. These are the two possibilities. Okay, so how is this going to work? We always start with the given. Okay, so our given is the concentration of nitric acid. So we start with the given and we say 1 times 10 to the negative 4 molar. Remember, molar means number of moles divided by liters of solvent. Okay, so in this case, the unit that we are going to write is mole per liter. Mole per liter of what? Of nitric acid, of course. Now, this we're going to multiply times the molar ratio in order to cancel nitric acid, because I need hydronium. Okay, this is the part A. I need hydronium ions. Okay, so in order to have that, I will be using this. Okay, this one, the second one, because I have nitric acid in the top and nitric acid in the bottom, so they will be cancelled. So I will multiply times the molar ratio, 1 mole HNO3 and 1 mole hydronium. Now this we can cancel. Okay, mole of nitric acid and mole of nitric acid are cancelled, so my amount in concentration Okay, my concentration will be this times this divided by that is going to give you 1 times 10 to the negative 4 mole in the top, in the bottom liters. Okay, now remember that when we have moles per liter is the same as having molar. Okay, so this is the same as saying 1 times 10 to the negative 4 molar hydronium. Now, this is correct, okay? But there's a standard notation to express molar of hydronium ions, and that way is to put hydronium, as you can see, inside brackets like this. Brackets, hydronium plus mean molar concentration of hydronium ion. So we're just going to rewrite this as 1 times 10 to the negative 4, and instead of molar of hydronium, we're just going to write hydronium in brackets, and this means the concentration of hydronium ions. Now, for the part B, that they are asking you to find OH minus, okay, we have a formula. Okay, so we have the formula KW. That KW means K is for constant, W is for water. So this is the ionization constant for water at room temperature. What is room temperature? 25 degrees Celsius. Okay, if the problem does not specify this, you have to assume that it occurs at a room temperature. So the formula to get the ion concentration, to get the ionization constant is you multiply the concentration of hydronium and hydroxide. So you know the constant because it's a given. Even if it's not written in the problem, it's given. You already found the concentration of hydronium, so you will isolate for hydroxide concentration. So you say, ionization constant of water equals hydronium ion concentration multiplied times hydroxide ion concentration. Now, we need to isolate for the one that we're missing. We need to calculate OH minus, okay? So, this multiplies my hydroxide ion, so it's going to be sent to the other side to divide. So you'll have KW divided by hydronium ion concentration equals to hydroxide ion concentration. Now, we say OH minus equals KW 1 times 10 to the negative 14 divided by the concentration of H3O, that is 1 times 10 to the negative 4. Okay? Now, how much is this? You do this in your calculator. I'm gonna do it once for you. 1 exponential negative 14 divided by 1 exponential negative 4. This gave me 1 times 10 to the negative 10. 1 times 10 to the negative 10. So this will be my OH concentration. And voila, this is it. This is it about hydronium and hydroxide concentration. Now we're going to learn about how to calculate the pH and pOH. Okay, how to calculate pH and pOH. Example, what is the pH of a 1 times 10 to the negative third power molar concentration of sodium hydroxide solution? So they are giving us a solution of a base. Okay, so in the first step, what we do is we're gonna do the reaction and the molar ratios just like we did in the example before, sorry. So we say NaOH. How does this ionizes? This ionizes in sodium ions plus OH ions. Now the number of moles is 1 mole of now NaOH produces 1 mole of sodium ion and 1 mole of hydroxide ions. Okay, now from this you can do the ratios, the mole ratios. So you will relate, because we're talking about a base, you will relate the given and the hydroxide ion. So you say 1 mole now over 1 mole OH minus, or you can write 1 mole OH minus divided by 1 mole of now. This is the mole ratios. Now we continue just like we did before, okay, just like we did in the example before. So we always start with the given and we say 1 times 10 to the negative third power. Remember, molar is mole per liter, okay? Mole over liters of what? Now times, okay, the molar ratio that I will use in this case will be the second one in order to cancel my moles of sodium hydroxide. So this will be 1 mole now in the bottom and 1 mole OH in the top. So when you multiply this, because you're multiplying and dividing by 1, you're going to get the same number as an answer. So this will be 1 times 10 to the negative third power. But remember that here we cancel nows, and the unit remaining is mole in the top, in the bottom liters. Mole per liters of what? OH minus. You already know that this is molar, and you already know that we need to write it in standard notation. In standard notation will be 1 times 10 to a negative third power, brackets, OH minus, and that's it. Now we have the molar concentration of hydroxide. Now, as I told you before, when this occurs at a where it's not specified, you assume that it's at room temperature. Okay. So you can get the hydronium concentration by using Kw. Okay. So you say Kw H3O plus OH minus. Okay, we need to isolate for hydronium concentration. So we say OH is multiplying, goes to divide. So hydronium concentration is equal to Kw in the top and below OH minus. Okay, so we're going to be using Kw as 1 times 10 to the negative 14. Unless it is specified to be a different temperature, this is the one that you're gonna be using. Okay, divided by 1 times 10 to the negative third power. Now, let's see. 1 exponential negative 14 divided by 1 exponential negative third. 1 times 10 to the negative 11. Hydronium concentration. Now that we have both concentrations, we can get pH and pOH. Now, pH is related to amount of hydrogen, okay? And pOH is related to the amount of hydroxide. So, for pH, we're going to be using hydronium, and for pOH, we'll be using hydroxide. Now, how do we do this? We have a formula. Okay, the formulas that we are going to be using is to calculate pH, it's negative logarithm of hydronium concentration, and for pOH will be negative logarithm of hydroxide concentration, and when you add them both should give you 14. Now, let's do this. pH, but I want to know pOH. I know that this is just asking you pH, but I'm teaching you how to get pH and pOH, which is basically the same procedure. Very, very similar, by the way. Now, this is negative logarithm of your hydroxide, hydronium ion. This is the same as saying negative logarithm of hydronium, that is 1 times 10 to the negative 11. Okay. Now the pH, it's the one that is related with the scale that I told you before. And that scale is called pH scale. Remember that for numbers up to 7 or less than 7, it's acid equal to 7, it's neutral, and more than 7 is basic. So what tells you about the acidity of a substance actually is the pH. So by knowing this, we're gonna know if our base is actually basic or acidic. So how do we do this in the calculator? Pay attention carefully, my guys. This is negative, this negative here, negative logarithm of parenthesis 1 exponential negative from here 11 close parenthesis equal 11. So because it's 11, it's a number that is more than 7, we can conclude that this is a basic solution. And that is true because we have a base here, so it makes sense. And voila, that's it. Now, if for some reason I ask you to calculate the pOH of this substance, we'll be applying the same formula. Negative logarithm, but instead of hydronium will be OH minus concentration. So this will be negative logarithm of 1 times 10 to the negative third power. Again, your calculator. Well, I'm gonna use my second calculator just to show you, okay, how to, in case that you have a different calculator. So this will be negative from here. Negative logarithm of 1 exponential negative 3 close parenthesis equal. This gives you 3. Okay, now just to make sure that we did it right, we can say, okay, let's check. 14 is equal to pH. pH was 11 plus pOH. pOH we got 3. 14 equals 14. So it's okay. We did it right. So that's it, guys. I'm going to highlight this. Okay. That's it, guys. Thank you for watching. Sorry for the time.